Okay guys, so this is how to test for a carbonyl. Now the carbonyls you'll have to test for are a ketone, which is a double bonded oxygen bonded to a carbon with two carbons either side of it, and an aldehyde, which is a double bonded oxygen bonded to a carbon with a carbon and a hydrogen. So this is your ketone and this is your aldehyde. Really important to remember those groups. Now there's two tests we can do. The first test we're going to go over is the Tollens reagent test. Now Tollens reagent is silver nitrate, so AgNO3 in aqueous ammonia. So what we would say is ammoniacal, how cool is that, silver nitrate. Ammoniacal silver nitrate. And what happens is when you mix this in solution with what you suspect is a ketone or an aldehyde, you get one of two reactions happening. So let's say I add a ketone. In fact, let's start with aldehyde. What happens is your silver breaks apart from your NO3, so we have Ag plus aqueous and NO3 minus aqueous, which is what all ions do in solution anyway. Now, don't worry about the nitrate ions, we can forget about them. Let's concentrate on our silver plus, our Ag plus aqueous ions. What's going to happen is it's going to react with your aldehyde, and we get a redox reaction. So oxidation is loss, reduction is gain. So my silver gets reduced, it gains an electron and becomes silver plus, just silver. And silver, without its charge, will not be soluble in solution, it won't be aqueous, it will form a solid layer. Now, if we have in a beaker or a container, this silver will form a layer around the edge of the container. So what you get is a silver mirror. And if you type in YouTube silver mirror test, you'll see some really nice demos of people doing that. Okay, so that would be my solid silver, and oxidation is loss, reduction is gain. So if this has been reduced and it's a redox reaction, this must have been oxidized. So when you oxidize an aldehyde, think back to your alcohols. The primary alcohol gets oxidized to aldehyde, and aldehyde gets oxidized to a carboxylic acid. So this will be changed into a carboxylic acid. And that's what happens with aldehydes. So if you know you've got either a ketone or an aldehyde, you add your ammoniacal silver nitrate, and if you get a silver mirror, you know you've got aldehyde. If I added a ketone to ammoniacal silver nitrate, so my silver is going to try and get reduced, and it's going to try and oxidize my ketone. But again, think back to that lesson on oxidation of alcohols. If I oxidize a secondary alcohol, I get a ketone. Can you then oxidize a ketone further? No, you can't oxidize a ketone. So this reaction, which I talked about a minute ago, cannot happen with a ketone. So your test would be, add your Tollens reagent. If you get a silver mirror, it must be an aldehyde. If you don't get a silver mirror, it must be a ketone, or at least definitely not an aldehyde. There's another test we can do, and that's my test. That is Brady's reagent test. Brady's reagent. And you're going to love this name, it's really easy to learn. In fact, I should probably make it a bit longer. 2,4-dinitrophenol hydrazine. I'm just going to highlight the bit at the end there, hydrazine. Now, what this does is this reacts with either an aldehyde or a ketone, so it can't really distinguish between the two of them, and it will form what we call, when it reacts with them, it will change from this to 2,4-dinitrophenol hydrazone derivative. So an aldehyde or a ketone will react with your 2,4-dinitrophenol hydrazine to make a 2,4-dinitrophenyl hydrazone derivative. And this is an orange precipitate. So what we do is we add our Brady's reagent to our mysterious chemical, and if we get an orange precipitate, we know it must be a carbonyl, because only carbonyls react to make this. That's an okay test. That can tell you whether you have a carbonyl, but that doesn't really tell you the exact identity of that carbonyl. There's a few further steps we can do to find that out, and here's what we do. So we've got our hydrazone derivative. Once we've got that, we filter and recrystallize it, and I'll just write these steps on the board. So filter and recrystallize. And the reason we do that is to purify it. Filtering and recrystallization gives us pure hydrazone derivative crystals. And I'll explain why we need it pure in a bit. After we filter and recrystallize it, to get it pure, we check its melting point. And this is why it needs to be pure, because we want to find the melting point of our hydrazone derivative, not our hydrazone derivative mixed in with a load of crap. So we just use the pure derivative. Once you've checked its melting point, you compare this to a big database. And on that big database will be the melting point of all your different aldehydes and ketones which super clever people have compiled over the years. So say like you've got a melting point of 62 to 65 degrees, the melting points are always a range. All you do is look in the book and check which other carbonyl had that melting point, and you've got your exact identity. And that is how to test for carbonyls.